One issue that students sometimes have when solving proofs is they get stuck. Now, I want to give you one tip to follow whenever you get stuck in solving a propositional logic proof. So here is the basic idea. Let's say you have a proof and you're working through it, you're moving along, and you get stuck. You're not sure what to do. Well, assuming you have looked at your premises and tried to use elimination rules to break those formulas down, chances are the next thing that you're going to need to do is try to make use of some introduction rule. So this is just a tip. It's not going to work every time, but the thought process here is to not look at the premises of your proof, but instead to look at whatever your conclusion is. You should look at the main operator of your conclusion and then try to focus your attention on an introduction rule. So a rule that usually has an I to the right of it as its abbreviation that corresponds to the main operator in this conclusion. So if you had, let's say, a conditional as your conclusion, you shouldn't look at conjunction elimination or biconditional elimination. You should focus your attention on, can I use a rule that introduces the type of formula I want into a proof? So you should look at rules, which in this case is conditional introduction, that corresponds to the main operator in the formula you want to derive. Let me give you one more example. Let's say your particular conclusion is a disjunction. So you want to solve for a formula of this form, phi or psi. You should not look at, let's say, conditional elimination or biconditional elimination. Instead, you should look at the disjunction rules. And in particular, you should look at rules that introduce this type of formula. So you should look at disjunction introduction. Okay, let's say we have this proof here, which is we have two premises, S and T, as well as P, and our conclusion is P or Q. Now, we started off this proof by saying, line one is a conjunction. Let me use conjunction elimination. I know if S and T is true, then S is true and T is true. And I did this by using conjunction elimination on line one. And then we get to line four and say, oh no, what do I do next? I'm not sure how to solve this. I actually need Q in the proof, but I don't know how to get it. I couldn't get it from line one. So what do? Well, again, let's follow our tip. Our tip is look at the conclusion. So our conclusion here is P or Q. That's our conclusion. What type of formula is it? This formula is a disjunction. The main operator is the V. So our tip says to look at the introduction rule that corresponds to this operator. And that rule would be disjunction introduction. So focus your attention on this rule. That rule says that if you have a formula, you can reason to a disjunction. And that disjunction has as one of its disjuncts the formula that you reason from. So if you had, let's say, A, you could reason to A or B. If you had A, you could reason to A or not B. You can reason, this can be whatever you want it to be, as long as it has the formula that you reason from as one of the disjuncts. Okay, so we looked at this rule, we thought about it a little bit. Let's come back over here. So we want P or Q. Well, we could say to ourselves, I have P, and so I can use this disjunction introduction rule to reason to P or Q. So let me do that. Let me say I have P, and then I can use disjunction introduction to introduce into the proof of a disjunction. And so I got this by using line 2, disjunction introduction. So the tip here again is if you get stuck, you should direct your attention at the conclusion of the argument, identify its main operator, and then look at the introduction rule that corresponds to that operator. That will give you a hint or a suggestion as to what rule you might think about in solving a proof. Let's take a look at another proof. In this case, I think it's worthwhile to pause the video, try to solve it yourself, and if you get stuck, remember what our tip is for solving proofs. Okay, hopefully you paused the video and did your best effort to try to solve this. Let's kind of check our work. So we have a proof which has one premise, Q and S, and then the conclusion is P right arrow Q. All right, so we might start this proof by just looking at the premise and saying, you know what, I can break this apart. I have Q and S, it's a conjunction, and I know that if a conjunction is the case, then the two conjuncts are the case. So if Q and S are true, so is Q on its own, and so is S on its own. And both of these steps in the proof are justified by using line 1 and this conjunction elimination rule. Now at this point, you might say, I'm stuck. I'm not really sure what to do. I don't know how to solve this. And you might start using rules blindly. The suggestion then is to not use rules blindly, but look at the conclusion. Our conclusion here is P right arrow Q. So what you would like to do is to introduce into the proof a conditional of the form P right arrow Q. Now, you might sort of say to yourself, well, how do I do that? Well, we know it's a conditional. We know the main operator is the right arrow. So let's look at that rule, the introduction rules that correspond to the right arrow. We're going to focus our attention on this rule and ignore the other rules for the time being. Now that rule looks like the following. It says that if you make an assumption of a formula and then you have reason to a formula, then you can reason from this entire subproof to a conditional. You can introduce into the proof a conditional where the antecedent or the formula to the left-hand side of the right arrow is the formula you assumed, and the formula that you reason to in the subproof is the right-hand side of that conditional. So what we want to do is we want this formula right there to be P right arrow Q, because this is our conclusion. So we want this phi here to be P, and we want this psi to be Q. So if we kind of plug that back into the structure of the rule, we want to assume P, because remember, we want this phi here to be P, and then we want to reason to Q. So we want this psi here to be Q. So let's think about that. Let's think about how we could sort of assume P, get Q, and then we can reason to P right arrow Q, which is our conclusion. Now, we're just going to make the bold move of starting by making an assumption. So we'll indent, and then we'll assume P. You can assume whatever you want, so there's no problem with this. We can make this assumption P. Now, our goal is to try to get Q in this subproof, to try to put it in there. Now depending on where you are, how many rules you have, there's a couple ways of doing this. I'm going to do it the sort of most laborious way, which is to say, well, my goal is to get Q into the proof. So I can take line 4, which is P, and line 2, which is Q, and conjoin them together. Because if P is true and Q is true, then P and Q is true. So this would be 2 and 4 conjunction introduction. And now, since I have this conjunction P and Q, if the conjunction is true, then both of the sides are true. So I could reason to Q. So this would be 5 conjunction elimination. All right. Remember, if I make an assumption P and reason to Q, I can reason to the conditional P right arrow Q. So let's do that. Let's just reason from our subproof 4 through 6 and say I'm going to write this conditional P right arrow Q. It essentially is just summarizing what is found at lines 4 through 6. Lines 4 through 6 says I can assume P. If we assume P, then Q follows. And line 7 is saying if P is the case, then Q is the case. So our justification will be 4 through 6, conditional introduction, which is this entire subproof. Now we have our conclusion, and we got our conclusion even when we got stuck at line 3. And what pushed us home, what was the important insight that we had, was to look at our conclusion, identify the main operator of that conclusion, and then focus our attention on an introduction rule that corresponds to that operator. Our conclusion was a conditional, and so we looked at conditional introduction. So this is a tip to keep in mind when, after you've broken down, let's say, the premises of a proof and you get stuck. This is one way that one thing to think about that might help you move forward in a proof.